Hey everyone, welcome to the Happy Flosser podcast. My name is Billy Lunt. I am your host, and I am here to talk to you about all things dental hygiene to support you on your journey through the dental hygiene program. Welcome, so glad to have you. As a dental hygienist, it is important to understand enamel in great detail. You have to understand composition, formation, as well as how enamel responds extrinsically to exposure of things like preventive medications like fluoride, and how it responds intrinsically to exposure of things like whitening products. In this episode, we're going to take a closer look at the histology of enamel formation. This process is known as amelogenesis. At the end of the process, the composition of the final product known as enamel is what we will be discussing. Are you looking for study sheets? I've created study sheets that cover the content of this episode. If you're interested or that's something that's going to help you on your learning journey, you can click the link listed right in the description of these show notes. Happy studying! Hey, are you in dental hygiene school or just got your acceptance letter and just started dental hygiene school and you're worried about how you're going to fit it all in, what the evaluations are like, what the key strategies you need to set up in order to be successful? You don't want to have worked all this time to get accepted into dental hygiene school only to make some pretty major errors in your first and second semester. I've put together a course that will really help you set yourself straight right out of the gate and get yourself started on the right foot in dental hygiene school. Whether or not you're just entering school or you've done your prerequisites and you're just well on your way halfway through, this course is designed to help get you straight and keep you straight so that you can become a dental hygienist. Click the link in the show notes and check it out. The composition of enamel is about 96% inorganic and in the form of hydroxyapatite. It's made up of about 3% water, and the remaining 1% or less is made up of organic matrix. An important consideration is that there is no collagen protein evident in enamel, unlike dentin, cementum, and the alveolar process where you can find collagen protein. You can find calcium hydroxyapatite in the other tooth structures as well, but it's at a lesser percentage, noted as inorganic, making the density of dentin, cementum, and the alveolar process a little less dense and not as hard and calcified as enamel. There are also trace amounts of magnesium, potassium, sodium, and fluoride. The configuration of crystals that make up the enamel crisscross at different angle configurations. And this crisscross configuration provides a protective layer in order to keep the inner portion of the tooth healthy in the challenging environment within the oral cavity. Amelogenesis can be divided into different stages. Now, some reference group these stages together, but for this episode, we're going to break amelogenesis into 6 stages of development and review the actions that occur in each stage of the process to really help the learning. Now, stage 1 includes the transition and differentiation process. And in this stage, there is an initial development of the dental lamina. The dental lamina folds inward and penetrates the mesenchyme. Now, the results of this is the transition through all the stages of tooth development that shape the crown of the tooth, starting at the cusp tip and then working downwards towards the CEJ. Once dentin is deposited, the pre-ameloblasts come into contact with the dentin. And this is when the cells differentiate into ameloblasts. This is initiated by the mesenchyme. Stage 2 is known as the ameloblast stage, and in this stage, there are a number of different epithelium cell types involved with the formation of enamel, and they take part in this stage. The cells become taller, and the nucleus of the cells move toward the opposite ends, and the cells become repolarized. The cells will arrange themselves very tightly and attach to one another. And at this point, the ameloblast is ready to deposit the enamel matrix. In stage 3, which is known as the initial deposition of the enamel matrix, in this stage, lots of changes occur in the ameloblast, and the protein enamelin is produced. Now, enamelin is the organic component of the enamel. The other two proteins that make up the enamel are the amelogenins and the ameloblastins. Synthesis of the enamel protein occurs in the rough endoplasmic reticulum. Now, Golgi complex condenses the enamelin and packs it with enamelin and hydroxyapatite crystals, and they get pushed into the matrix. The matrix migrates to the back of the cell in order to be released. Ameloblasts are responsible for the development of adding calcium to form the hydroxyapatite as the matrix is secreted. Stage 4, the formation of the tomes process. In this stage, the first incremental step of the enamel is actually formed. The ameloblasts begin to move away from the dentin surface, and they produce approximately 4 micrometers of enamel matrix a day. The tomes process contains granules of matrix and organelles needed in the mineralization, design, and production of the enamel. A terminal bar separates the body of the ameloblast from the narrow projection of the cytoplasm. Now, in stage 5, which is called the ruffled end of the maturation, in this stage there is deposition of enamel, and at this point the ameloblasts advance toward the outer surface and really begin the process of adding calcium to the enamel in order to form the hydroxyapatite. There's a decrease in the volume and organelle content in order to help effectively transport the minerals into the deposited enamel. The ruffled plasmalemma begin their pumping action. Inorganic materials such as hydroxyapatite crystals are pumped into the enamel, and these cells appear at the end of the ameloblast and are part of the cells nearest the enamel. The cells will end up developing these elongated folds in the plasmalemma, with several mitochondria located between the folds or the ruffled ends. The increase in the mitochondria indicate that energy is reconfigured in order to pump the minerals into the enamel. Now, due to the size of the crystals, this requires a lot of energy from the cell. In stage 6, which is known as the smoothing of the maturation stage, in this stage, the crystals have been deposited and the cells change yet again. At this point, there are fewer ruffled edges, and in time, the areas will become smoother. Organic materials like protein and water is pumped out of the matrix. This requires so much less energy from the cell, and the result of this action is complete mineralization of the enamel matrix. Stage 7 is called the protective layer. The mineralization process has occurred, and at this point, the ameloblasts become shorter and join the reduced enamel epithelium, which will fuse with the oral mucosa at some point, creating a protective pathway toward the eruption process to occur. The ameloblasts are lost forever. The fused tissue disintegrates during the eruption process, and this prevents any further appositional growth of enamel. The mineralization process can continue from things like fluoride or calcium, and this is called the post-eruptive phase. The entire reduced enamel epithelium can later become part of the nasmyth membrane. The reduced enamel epithelium and the oral mucosa develop in the area of the oral epithelial tissue. Now, the basic unit of enamel is composed of rods. The enamel matrix secreted into the pits that were developed around the tomes process, and the result is a tightly packed mass of hydroxyapatite crystal rods. Now, as the ameloblasts move forward, the enamel matrix fills the holes. Picture the enamel rods being stacked up like logs that extend from the DEJ, remember the dento-enamel junction, to the outer enamel surface. The general orientation of the enamel rods are perpendicular to the DEJ, and they curve slightly. The curve is reflective of the movement of the ameloblasts. Now keep in mind the enamel of most of the primary dentition is formed before birth, right? The crystals in the rod groups bend to the right or the left at different angles, and the result of this is an increase in the strength of the enamel matrix. These pathways are also known as Hunter-Strager bands. Now, sometimes gnarled enamel can be seen in the cusp tip areas. In this region, the enamel rods twist and bend, adding strength to the enamel as well as to the cusp tip. Enamel tufts are little projections that extend from the dento-enamel junction into the enamel, a very short distance. Now, these tufts contain a greater concentration of enamelin. It's important to know these areas have much less mineralization. Enamel lamella are projections from the dento-enamel junction into the outer surface of the enamel. The enamel lamella appears as thin little cracks in the enamel surface. These areas are partially mineralized, and the lamella is narrower and longer than what you see with the enamel tufts. Enamel spindles are located at the dento-enamel junction, and these spindles are extensions of the odontoblast process across the dento-enamel junction into the enamel during formation. Dentinal tubules will become embedded in the newly formed enamel. The spindles are much shorter than the enamel tufts or the enamel lamella. It's important for you as a student to really understand the histology process of enamel formation and to really understand what actually makes up the enamel and picture what it looks like if you were to look under a microscope. This will really help you in the clinical setting when you are working with patients who have increased sensitivity or are having trouble with mineralization issues, having trouble with white patches or gray patches on their teeth, or don't really know what's causing sensitivity, or maybe they want to whiten their teeth. It's really important for a number of different clinical considerations for you to understand the histology of enamel formation. For you as a student, once you understand the histology of enamel formation, then you can start to connect the dots on how that enamel formation connects with some of the preventive measures that you take as a clinician to help your patients maintain and keep their enamel strong and healthy. So it's really important for you to understand the histology component of enamel. I would be remiss in talking about histology of enamel formation if I didn't talk about some of the concerns that we have as clinicians when we see some of the ways that patients lose or have destruction of their enamel. And this can happen in a number of different ways. One of the most common ways is through caries, right? The patient will lose some of their enamel matrix as a result of a bacteria causing a lesion in the enamel as a result of dental biofilm. And we see this very often. And this is quite honestly one of the most common ways to lose enamel structure in the oral cavity. And it's also one of the most common ways that your patients understand tooth loss and enamel loss as well. But there are also other ways for patients to lose enamel structure. Abfractions can occur, which is a V-shaped notch that usually occurs in the cervical third of the crown of the tooth, usually right at the gingival margin. And this happens as a result of a heavy occlusal load on specific teeth. And we will see this in several situations with our patients. So that's an important thing for you to understand as a clinician. Patients can also lose enamel structure from erosion due to chemical exposures, very acidic exposures. This could be because of an acid reflux issue or a diet issue where somebody is ingesting very acidic foods or they are regurgitating some of their acidic stomach fluids into the oral cavity. Abrasion is another way for patients to lose enamel structure, and this is from aggressive, prolonged toothbrushing with abrasive materials or a very aggressive brushing. And so that is something that we want to pay close attention to when we are in the clinical setting. And then just attrition, we'll see some of these shiny wear facets on the occlusal surfaces or missing cusp tips on our patients. And this lets us know that they have attrition going on. And this could be from grinding their teeth. Usually we see abfractions with patients who are clenching their teeth, and we see attrition with patients who are grinding their teeth. And both of those are indicators of loss of enamel. If you're listening to this podcast, that means that you're most likely a dental hygiene student, because otherwise I don't know why you would listen. I just want to share with you that you are just my absolute favorite group of people. You work hard, you're organized, you have good time management skills, and know that your faculty is trying to help build you into the clinician and dental hygienist that you want to become. It is a tough journey to go from the beginning to the end of the process to become a dental hygienist. I know that just as well as all of you, as you're learning, know that. Keep with it, keep learning, keep growing. Anytime you have an opportunity to study with friends, review material, and try to recall some of the information, take advantage of this. You may miss your friends, you may miss your family, but I promise you this is just a season in your life. Keep your eye on your goal. Keep the reason why you want to become a hygienist close to your vest, close to your heart, so it will keep you motivated to continue to grow, improve, and learn. I'm sure you're tired at this point. It is an exhausting journey, but I can tell you firsthand, it is so worth the effort. And you will get to the end and realize that you have so much more to learn, and you will want to. You will desire to know more. We're always learning and growing. There is no finish line to the learning journey of a dental hygienist. So I implore you to continue to push yourself forward. I'm proud of all of the efforts that you've made so far. And I want you to keep listening and keep growing and keep doing everything you need to do to be successful. We are all rooting for you. I would invite you to ask any questions at all that you need answered. Sometimes questions come up when you're listening to this podcast. If you have a question, most likely someone else has the very same question. I'd be happy to answer it and would probably share it in a future podcast.